Hello and welcome everyone. In this video we'll discuss about probability. What is probability? It is a numerical value that describes the likelihood of the occurrence of an event in an experiment, the chance of something to be happen. In life, probability has its own importance because we need to predict the probability or the chance of something before we try. So there are some terminologies that we need to raise here. Let us start by those points. Okay, the first point is experiment. What is experiment? In probability, experiment is the process. It is process. Simply we can say it is a process, like that of tossing a coin or rolling a die, or we can say drawing a card. All these are process. When you toss a coin, you don't know the outcome. Later on, okay, the total possible outcome will be possibility set. I'll come back to that. And after roll a die, what numbers will be appear at the top? That's going to be the Unevent, but the total possible outcome will be possibility set. But the first step in case of probability, it's an experiment. The experiment is like, here are some examples. Tossing a coin. If you toss a coin, okay, you know a coin it's a circular, it has two faces, top and like one of the faces head, the other face is tail. Which one appear at the top after tossing a coin? That is the next step. But the first step is tossing a coin. That is experiment. Okay, let's go to the next terminology. The second point or the second terminology under probability, it is sample space. Sample space is, we can call it sometimes probability set. We can call it probability set. Or we can say it total possible outcome. For example, you know a die. A die is it's a kind of cube. It has 6 faces. In each face, numbers are written. Okay, those numbers are 1, 2, 3, 4, 5, or 6. There is no another number in each face. One of the number may appear at the top, either 1 or 2, 3, 4, 5, 6. So these are the total possible outcome. After rolling a die, there is no chance or there is no probability to observe a number which is greater than 6, like number 7, number 8. Impossible, you can't. Even a number which is less than 1 cannot be seen, like number 0 or negative numbers. Impossible. That those total probability or total sample space, probability set, we call them sample space. So the first terminology that we have to be clear is sample space or probability set or total possible outcome. After tossing a coin, as I told you before, after tossing a coin, the chance to be observed at the top will be either head or tail. There is no number here, head or tail. If you draw a card, in playing card, you know, there are 4 colors, 2 colors, 2 red and 2 blacks. The blacks are flower and arrow, and the reds are diamond and heart. Anyways, 52 cards are there. So what is the probability to get a number which is 10 or 8? It depends on the color also. So we need to be clear there. When we are coming to example, we'll try to clarify that one. But in general, what is probability set? The total possible outcome. So in case of drawing a card, the total possible outcome are the 52 cards. In case of playing card, these are the first 2 terminologies. Let's go to the next one. The next one is an event. An event is any subset of sample space. For example, as we said before, after rolling a die, what is the probability of getting, okay, the event, I'm talking about the event, getting even numbers. Those even numbers are 2, 4, and 6. After rolling a die, there is no other even number. There are no other even numbers other than 2, 4, and 6. The total possibility sets are, we said already, 1, 2, 3, 4, 5, 6. So the event observing even numbers are these. If it says odd number, the odd numbers, it is 1, 3, and 5 there. Or the question may say observing a number which is greater than 5. That's going to be 6, just only 6. So an event is any subset of sample space, the desired outcome. That is what means event. So we need to be clear. First we define what is experiment, just a process, sample space, or probability set. That is a total possible outcome. And next we are trying to define what means event. Event is the desired outcome. That is a subset of the sample space. For example, when we are saying the event which is even number 2, 4, 6, these are the subset of the total possible outcome 1, 2, 3, 4, 5, 6. So remembering the previous terminologies, now let's come to the main definition, probability of an event. Okay, we are going to the calculation part now. Probability of an event, here is the formula. It says probability of an event is the number of favorable outcomes, or the desired outcomes, or the number of events, we can say, divided by the total possible outcome. What means event? We have seen it here. What means total possible outcomes? We have seen it here, sample space. So the probability of an event means it is the number of favorable outcomes divided by total possible outcome. We can take one simple example here. For example, after rolling a die, probability of an event which is observing even number. Those even numbers we have seen here, there are 3 numbers we have, 3 chances we have. So 3 out of 6 outcomes, because it's about a die, we are talking about a die. So let us see some formal examples, and then it will be clear. Anyways, this example we can take it for the probability of an event observing even number after rolling a die, which is 3 out of 6. This means we can simplify 1 over 2, or we can write this one as a decimal. 1 divided by 2 will be 0.5, or we can write this one as a percentage, which is going to be 50%. So let us see some more examples on this. Here is the first example. It says a fair coin is tossed once. What is the probability of getting head? It's a coin. So there are 2 possible outcomes here. The sample space is just 2, the number of samples, because either head or tail up here. So the number of sample space here, the number of sample space is equal to just 2. What is the probability of getting head? That means the number of the event. After tossing a coin, we can observe only just 1 head and 1 tail. So the number of event is 1. So the probability of the event will be, we said already, the number of the event divided by the number of the sample space, which is 1 over 2, or 0.5, or 50%. That's it. First example. Second example, let's see. Here is the second example for us. It says a die is thrown once. Okay, it's talking about die. So the number of sample space at this point, we have to be clear, just once. So 6, the number of sample space, the total possible outcome, because we are talking about a die. A die has 6 faces. It's a cube. In each face, numbers written. Those numbers are 1 to 6 already, we know it. So what is the probability that the number appearing will be just number 3? It says here, number 3. That means the probability of the event, okay, let's change the color, can make it black. So the probability of the event will be, number 3 is just 1, so the number of event here it is just 1, because number 3 it says A. So the probability of the event is 1 over 3. 1 over 3 means it is 0.33 or 33%. So we need to know how to express even the given probability, fractional form or decimal form or percentage. This one is unlikely, we can say. By the way, the probability scale at the same time, here we need to be clear. Probability scale, there is 0 chance and there is 1 chance maximum. 0 chance is impossible event, we can say, impossible. 1 chance, it is certain, or we can say it sure event. 1 over 2 chance, it is even chance, just half. But if the probability of an event is between 0 and 1, or less than 50. By the way, how 1 over 2 means it's like 50%. This one in percentage we can say is 50% or 0.5. If the percentage is less than 50%, it is, we call it unlikely. Unlikely. If it is greater than 1 over 2, between 1 over 2 and 1, it's going to be likely, like most probably. But between 1 over 2 and 0, it is unlikely. So the probability of an event observing a number 3 is unlikely, because 33%. That is the answer for A. What about the answer for B? Let's do it. It says a number less than 5. What are those numbers? We have the number of event, the sample space will not be changed as it is. The number of the sample space is 6. But a number less than 5, what are those numbers? In case of throwing a die, it's going to be 1, 2, 3, and 4. We have 4 chances. So that the probability of the event will be 4 over 6. Okay, let's go to the next page and let's do it. So it's going to be the number of sample space, already we said, which is 6, and the number of the event, the number less than 5, what they are 4 already. So the number of the probability of the event, the probability of the event is going to be 4 over 6. We can simplify, it's going to be 2 over 3, or we can write it decimal for 0.66. It continues, or this is the same as 66.7%. This is greater than 50%, so we can say this is likely. Likely means like most probably. This is it. Let's add more examples. The examples will clarify much better. Okay, the next example, that's going to be our third example. What does it say? A die and a coin tossed together. Okay, simultaneously. Okay, then sketch a tree diagram showing the outcome of the experiment. There are a coin and a die. They are tossed together. Okay, so the coin has 2 outcomes, either head or tail. There is no another chance for the coin. But this head may appear with the number 1 or the number 2 or the number, so there are 6 possible combinations here, because a die has 6 faces, we said already. So 1, 2, 3, 4, 5. The 6th one we can write it here. Number 1, number 2, number 3, number 4, or number 5, or number 6. Okay, that means head with 1, head with 2, head with 3, head with 4, head with 5, and head with 6. The head may be combined with either of the 6 numbers. The same manner, the tail will combine with 6 numbers. 2, 3, 4, 5, 6. So those numbers are 1, 2, 3, 4, 5, 6. So tail 1, tail 2, tail 3, 4, 5, and 6. We can show in tree in this form or the total possible outcome. So the number of sample space at this time, when you throw a coin in the die, the number of sample space is 12, because the head will be combined with 6 number possible outcome. When we are talking about possible outcome, the head and the number 1 may appear at the top, and the head and the number 2, head with 3 or 4, 5, 6. The same manner, the tail may appear with 1, the tail with 2, with 3, with 4, 5, 6. So that the total, the number of sample space will be 12. Actually, the head, the coin has 2 outcomes, and the die has 6 outcomes. You can multiply. 2 times 6 will be 12. That is the total sample space. We have this one. And what is asked B? The first one we answered already. We are asked to show or to sketch a tree diagram. We are done here. B, it says, what is the probability of getting a head and an even number? What are the head and even number? That means head and 2, head and 4, and head and 6. These are the numbers. Once again, let me circle it. Head and 2, head and 4, and head and 6. We have 3 chances. So we can answer now here. The probability of the event will be 3 over 12. 3 over 12 means we can simplify 1 over 4. 1 over 4 means it's 0.25 or 25%. Or unlikely, we can say. It's like less than 50%. so unlikely. So we need to be systematic. We need to know the properties in general. Okay, let's go to the next one. The next question is what the probability of getting a tail and an odd number? Okay, again, tail and odd numbers, they are visible here. Tail and 1 odd, and tail and 3, and tail and 5. So we can answer here. 3 chance we have again. 3 over 12, or 1 over 4, or 0.25, or 25%, or unlikely. We have to respond in all ways. This is the answer. Okay, let's add one more example, and that's going to be enough. But we need to remember, again, like I said before, for any event, okay, probability, it is between 0 and 1. It cannot be less than 1. I mean greater than 1. It cannot be greater than 1. It cannot be less than 0. It's between 0 and 1. 0 means impossible, something may not happen, cannot happen. And 1 chance means 100% just sure event. Or we can say 13, and 0 is impossible. Those are previous lesson, but this time we are talking about simply probability of event. Okay, the last example for today, it says a bag contains 5 red balls. Okay, 5 red balls. 1, 2, 3, 4, 5. 5 red balls we have, and it says here it is 5 red balls, and again 3 black balls. Okay, let's try to show 3 black balls. 1, 2, 3. Okay, then again these are 3 black balls and 4 white balls. 1, 2, 3, 4. So this is a bag. Considering this as a bag, there are totally the number of sample space, means the total number of elements we do have, the total number of balls we have here. 5 plus 3, 8, 8 plus 4, which is 12, the total sample space. And in A, what is the probability that a ball drawn is white? So the whites are 4, so the number of event is equal to 4. So the probability of the event will be, the event, the probability of the event this time, the event is 4, so 4 over 12, which is 1 over 3, which is 0.33% decimal form, and which is 33%, which is unlikely again. This is the answer for A. B, the probability red. The probability of red will be, the red balls are 5 out of 12. You can divide and check. 5 out of 12 means around 0.61, 0.41 nearly, which is unlikely still. And C, the probability of black. The probability of black will be 3 blacks we have, 3 over 12, which is 1 over 4, 0.5, and 25%, which is still unlikely. So these are some of the examples and definitions of probability and some terminologies on probability. So let's have some exercise and let's practice with the exercise, and let's end up here. So for today, let this exercise be our homework. We can practice using this exercise what we learned. It says a bag contains 100 identical cards on which the number 1 to 100 are marked, and a card is drawn randomly. Find the probability that the number on the card is even number, odd number, multiple of 7, multiple of 5. Different questions are there. So thinking of numbers from 1 to 100 and observe the event, the total number of sample space is like 100 numbers or 100 cards you have. Therefore, in that pattern, try to do the exercise. Thank you for watching. Keep watching for more videos. Thank you.